Today, I am going to discuss sketching the graph of the polynomial functions. Sketching the graph of the polynomial is easy if the important features of the graphs are known. And knowing the characteristics of the graph of the polynomial functions are necessary. So first, the graph of the polynomial function is a smooth curve. So, for an example, we have here a graph. We can say this is the graph of a polynomial function since all the turning point of this graph was done smoothly. Then, second characteristic, it should be a continuous line. So if your graph looks like this one, so this is the incorrect graph for the polynomial function since it has a sharp corners. Again, the graph of the polynomial functions, every turning point was done smoothly. So if you do the graph for the polynomial functions, make sure that you have a nice transition, just like this one. Then it should be a continuous line. So if your graph looks like this one, although you have no sharp corners, but your graph is a broken line. And this is also the incorrect graph for the polynomial functions. So this is the correct one. It does not have a sharp corner and also it is a continuous line. So please remember that. Now, in sketching the graph of the polynomial functions, there are some features that we must know. First, the degree and the sign of the leading coefficient of the given polynomial functions. So, first features that we must know is the degree together with the sign of the leading coefficient. The degree and the sign of the leading coefficient tell us about the end behavior of the graph. So, our degree either it is an even number or an odd number. And the sign of our leading coefficient, either it is a positive or negative. Just like this one. Positive and negative. Now, if our degree is an even number and the sign of our leading coefficient is positive, therefore, the end behavior of our graph both rising. Then, if the degree is even number but the sign is negative, then the end behavior of our graph are both falling. And if the degree of the given polynomial is an odd number and the sign of our leading coefficient is positive, therefore the end behavior is falling and rising. And last, if our degree is an odd number but the sign of our leading coefficient is negative, therefore the end behavior of our graph are rising and falling. So these are the features that we must remember when we are dealing with the degree and the sign of the leading coefficient. Next, the next features is the zeros or the x-intercept of the given polynomial functions. So we have here the zeros or it is the x-intercepts. So the zeros or the x-intercepts tell us where the graph touches or crosses to the x-axis. Then, we have to know the y-intercept. The y-intercept, it is the constant of the function. Then it tells us where the graph must crosses to the y-axis. Then, it is also necessary to know the multiplicity of the zeros. The multiplicity will tell us about the behavior of the graph once it touches or it crosses to the x-intercept or to the zeros. Then our multiplicity, either it is 1, an even number, or an odd number greater than 1. So, if the multiplicity of the zeros is 1, then the graph will pass through. So, the graph will pass through to that given zeros. Then, if the multiplicity of that given zeros is even, then the graph will bounce. Then, if the multiplicity is odd number but greater than 1, therefore, the graph will have a little bend. So all of these we must remember in sketching the graph of the polynomial functions. So now, without further ado, let's try this given example. How about this one? Let's try to sketch the graph of this given polynomial function f of x is equal to x cubed plus 4x squared minus 4x minus 16. So before we can sketch the graph, we have to know some important features of this given polynomial function. So first is the degree and the sign of the leading coefficient. So the degree of this given polynomial function, remember our degree either even or odd number. So the degree is the highest exponent, and the highest exponent is 3. Then 3 is an odd number, so therefore the degree is an odd. Then the sign of the leading coefficient here is the positive. The leading coefficient, it is the term with the highest exponent. And the term with the highest exponent of this given polynomial is this one. And the sign of the coefficient here is positive. That is why we have here positive. So the degree and the sign are positive and odd. So therefore, we can say the end behavior of the graph of this given polynomial function is falling from the left and it will rises to the right. So this is the end behavior of our graph. Now, the next important is the zeros, or it is the x-intercept. Now, we can find the zeros or the x-intercept by using the synthetic division. Or you can use the factoring method if the given polynomial is factorable. But since we cannot able to find easily the zeros, so I have to jump to the other important, which is the y-intercept. The y-intercept, it is the constant of the given function. And our constant is simply the negative 16. So therefore, the y-intercept is negative 16. Then the last important that we must know is the multiplicity of the zeros. But since we have now yet the zeros or the x-intercept, then we cannot able to find the multiplicity. It is because the multiplicity depends on how many times the zeros will appear. So we have to know first the zeros and we have now the multiplicity. So now, let's find the zeros of this given polynomial functions. So I use the synthetic division. So we have our first coefficient is 1, followed by positive 4, and negative 4, and negative 16. Now I'm doing the zeros, right? For the zeros or for the x-intercept. And for our divisors here, let's try the positive 2. Then, bring down 1. 1 times 2 will give us 2, and let's add here, this is 6, and this becomes 12. Negative 4 plus 12 is positive 8. Positive 8 times 2 is positive 16, and this becomes 0. So correct, this is one of the zeros. So we have here positive 2. But since we have now the first zeros, so we have to subtract 1 to the exponent. So it becomes now the quadratic equation. So it becomes x squared plus 6x plus 8 equals 0. And since we are dealing with the quadratic equations, that means we can use any method in solving quadratic equation. So how about factoring? Now, is this a perfect square trinomial? Yes. So, what is the factor of 8? And if we add the factors, we have a sum of positive 6. So, that is 4 and positive 2. Correct. So, we have here x plus 4 and x plus 2 and equal to 0. And this means we have to use the ZPP or the zero product principles, which means we have to equate all the factors equal to 0. So, automatic, we have here x is equal to negative 4, and this one we have here x equals to negative 2. And this is our other zeros. So, we have here negative 4, negative 2. Remember, the number of zeros that we have to find depends on the highest exponent. So, since our degree is 3, so therefore we have to find 3 zeros. And we have here now. Then, since we have the zeros, then we can now find the multiplicity. Okay? So, I erase this one first. So, again, the multiplicity depends on how many times the zeros will appear. So, how about positive 2? How many times the positive 2 appear? Simply just 1. So, the first multiplicity is 1. How about negative 4? The negative 4, how many times it will appear? Also 1. The negative 2, also 1. So, therefore, all the zeros has a multiplicity of 1. Then after getting all this data, we have to find the other points which serve as the turning points of the graph. So to do that, we have an ordered pair. So first, we plot the given zeros. So we have here 2, positive 2, we have here the positive 2. Then we have here the negative 4, and we have here the negative 2. So these are the zeros or the x-intercept of this given polynomial function. What we need is the other ordered pair which serves as the turning point. So we use now the negative 3, negative 1, and positive 1 as our x-intercept. Then let's find the value of y if our x is negative 3, negative 1, and positive 1. So do not include the zeros. Right? So we have now, let's do it now. We will have x and y. So only use the number between the two endpoints of the graph. So this is our endpoint, positive 2 and negative 4. So the number between the endpoints is what we're going to use as our value of x in order to find the y. Okay, so our first is negative 3. If x is negative 3, what should be the value of y? So if we have here negative 3 raised to 3 is simply negative 27. Okay? Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Then negative 3 squared is positive 9 times 4 will give us positive 26. Then negative 3 times negative 4 will give us positive 12. Then copy the constants, negative 16. Then evaluate. Negative 27 plus 36 is positive 9. Positive 9 plus 12 is, positive 21. Positive 21 minus 16 is positive 5. So, if x is negative 3, our y is positive 5. Now, the next is negative 1. Do not include the zeros, okay? Negative 2 is 0, so you don't have to use it as the value of the variable x. So now, if our x is negative 1, so here, negative 1 cubed is simply negative 1. Then, negative 1 squared, well here, again, negative 1. Then, negative 1 squared is positive 1 times 4 is positive 4. Then, negative 1 times negative 4 is positive 4. And copy the constant, negative 16. Then, evaluate. Negative 1 plus 4 is positive 3. Positive 3 plus 4 is 7. 7 minus 16 is negative 9. So, if x is negative 1, our y is negative 9. Last is positive 1. If x is positive 1, what should be the value of our y? So simply, 1 cubed is simply positive 1. Then 1 squared is 1 times 4 is positive 4. Then 1 times negative 4 is simply negative 4. This becomes negative. And capital constant, negative 16. And now let's evaluate. So these two are cancelled. They are additive inverse. So 1 minus 16 is simply negative 15. So these are our other points that we need to plot in the Cartesian plane because it will serve as the turning point of the graph. So first, we have negative 3 and 5. So our x is negative 3, the y is positive 5. So the first turning point is in this point. And we have here negative 1, negative 9. So negative 1, negative 9. So this one. This is the second turning point. And the third is positive 1, negative 15. Positive 1, negative 15. Oh, let's assume this is negative 15. Okay? So positive 1, negative 15. Just assume this is the negative 15. We have no space. Okay, so now we can graph. So our first point, we have here negative 4. Remember our end behavior, it will falls on the left and it will rise to the right. So we have here the first point, negative 4. So once the graph touches to the negative 4, we have here the 0 is negative 4, our multiplicity is 1, so that means the graph will pass through and go to this first turning point. So be careful to have no sharp corner. Then the graph will come to negative 2 and the multiplicity of this negative is 1, so that means the graph will pass through to that intercept. Then go to the next turning point, which is this one, negative 1 and negative 9, this point. So 1 negative, and go to the y axis, which is a point negative 16. So it will process now to the y axis and go to the third turning point. At this point, positive 1 and negative 15. Go to positive 2. And remember, once the graph touches to the x-intercept to positive 2, our multiplicity is also 1. So therefore, the graph will pass through that point. And this is the end point of the graph. So simply just write the arrow heads. So look, the end points of our graph is correct. So this is how we sketch the graph of the polynomial function. We have to know first the degree and the sign of the leading coefficient, the zeros, the y-intercept, and the multiplicity. Then after that, you have to find the other points which serves as the turning point of the graph, the other ordered pair. Okay? So I hope this is clear. Let's try another example. Let's try to sketch the graph of this given polynomial function. The f of x equal to negative x cubed plus 3x squared minus 2x. So again, we have to know first the degree and the sign of the leading coefficient. So the degree is 3, so we can say it is an odd number. And the sign here is negative. So add negative. Therefore, we can say the end figure of our graph is rising and falling. Then, we have to know the zeros or the x-intercept. But we can able to determine immediately the value of the zeros. So, let's try to get the y-intercept. Again, the y-intercept is the constant of the function. So, since there is no constant here, automatically our y-intercept is 0. The next is the multiplicity. So, we can't able to find the multiplicity since we have no 0. So, let's find the zeros first, then we can have the multiplicity. So, now, I'll copy first this given equation, negative x cubed plus 3x squared minus 2x. This time, I can use factoring since there is no constant here. Automatically, that this given polynomial has a common factor. All the terms has a common factor. So therefore, I can use a common monomial factor. So I can factor out that common factor. So let's say the common factor of this is negative x. Then negative x cubed divided by negative x will give us positive x squared. Then positive 3x squared divided by negative x will give us negative 3x. And negative 2x divided by negative x is positive 2. Then look, the terms inside the parentheses is perfect square trinomial. Therefore, we can factor this one. So copy first negative x. Then, since this is a perfect square trinomial, therefore, what's the factor of the constant? And if we add that factor, we have negative 3. So simply x is minus 2. And the other is x minus 1. Am I right? Negative 2 times negative 2 is positive 2. But if we add negative 2 plus negative 1 is negative 3. So therefore, this is the correct factor for this given perfect square trinomial. Then, we can equate this to 0. So this means we can use the ZPP or the zero product principle that we can equate each factor equal to 0. So negative x equal to 0 and this one x minus 2 is equal to 0 and x minus 1 is also equal to 0. Then automatically we can find the zeros. So x here is positive 2 and this one positive 1. So these are the zeros or the x-intercept of this given polynomial function. So we have here 0, positive 2, positive 1. Then look, there is no repeating zeros. Therefore, we can say the multiplicity of the zeros are simply 1. They are all 1. Okay? Now, our y-intercept is 0. So we have here 0. And our first x-intercept is also 0. Then we have here positive 2 and positive 1. So these are the zeros, the x-intercept and the y-intercept of this given polynomial functions. So let's have at least one ordered pair. Let's try this one, negative 1. Let's say if x is negative 1, what should be the value of our y? So negative 1 cube is simply negative 1 times negative with now positive 1. Then negative 1 squared is positive 1 times 3 is positive 3. Then negative 1 times negative 2 is positive 2. So If our x is negative 1, our y is positive 6. So this is the first one. So we can graph now the given function. So let's start with this point. So we can say, so remember this is our endpoint. So we have here now. Then it goes to the center or the origin of the Cartesian plane and go to positive 1 and go to positive 2 and here it goes. So the graph of this polynomial function looks like this one. So I hope this is clear. Let's try another one. Let's try to sketch this given polynomial function. F of x is equal to x raised to 4 minus 8x squared plus 16. So now, let's find the degree and the sign of the leading coefficient. So the highest degree is 4, and 4 is an even number. Then the sign of the leading coefficient is positive. So even positive, therefore we can say the end behavior of the graph are both rising. Then the zeros, so we cannot automatically find that one, so jump to the next important, which is the y-intercept. The y-intercept is the constant of the function, which is positive 16. So we have here positive 16. Then the multiplicity, we have to find first the zeros, and we can now find the multiplicity. So observe the given polynomial. We have here x raised to 4 minus 8x squared plus 16. Is this a perfect square trinomial? Yes. There is a factor of positive 16 that if we add that factors, we get a negative 8. So, simply over here, x squared minus 4 and x squared minus 4. Am I right? Negative 4. If we add this one, we get negative 8. And if we multiply negative 4 times negative 4, we have positive 16. So, we can now equate this one to 0. So, x squared minus 4 is equal to 0. X squared minus 4 is equal to 0. Then, transpose over x squared equals to positive 4. X squared is equal to positive 4. Then, we both use square root property on both sides of the equation in order to cancel the square to be x. Then, the square root of 4 is simply positive negative 2. Same this one. So, our x simply positive negative 2. So, we have now the zeros. Positive 2, negative 2. So, positive 2, negative 2. Then the other also positive 2, negative 2. So, we have now the 4 zeros, which is equal to our highest exponent 4. Then observe, how many times the positive 2 appear? Twice. So, therefore, the multiplicity of positive 2 is 2. Then, negative 2, how many times it will appear? Also twice. So, therefore, the negative 2 has a multiplicity of 2. So, our multiplicity are both even. So, that means, so I can erase this one first. If we graph this one, the graph will bounce once it touches to the positive 2 and negative 2. So we have here now positive 2, negative 2. These are our zeros. Positive 2 and negative that one. So we have here negative 1 and positive 1. So we have to find the ordered pair of these two numbers to serve as a turning point of the graph. So let's do that one. So our first is negative 1. If x is negative 1, what should be the value of our 1? So negative 1 raised to 4. Negative 1 times negative 1 is positive 1. Times negative 1 is negative 1. Times negative 1 is positive 1. Then, negative 1 squared is negative The negative 1 square is positive 1 times negative 8 is negative 8. Then just copy the constant positive 16. Then evaluate. 1 minus 8 is negative 7. Negative 7 plus 16 is positive 9. So if our x is negative 1, our y is positive 9. So negative 1, positive 9. So this is the first turning point. Then we have positive 1. Positive 1 raised to 4 is simply positive 1. Then positive 1 squared is positive 1 times 8 is also negative 8 and plus 16. So that means also positive 9. So 1 positive 9. So let's say this is our point. Okay? Our y-intercept at positive 16. So let's try this our positive 16. Just assume this is at the positive 16. Okay? We have no space. Now we can sketch the graph. So let's start with negative 2. And we all know this is the end behavior of the graph. So positive 16. So let's do this one. And once the graph touches at negative 2, we all know that the multiplicity, once the 0 is negative 2, is even number. Since it is 2, so therefore the multiplicity is even number. And we all know if the multiplicity is even number, therefore the graph will bounce. So that means we'll back. Then go to positive this point and go to positive 16 and go to this point and go to positive 2. And once the graph touches to the positive 2, the multiplicity is also even number, so the graph will bounce. So it will move, will back upward, and that is the graph. So this is the graph of the given polynomial function x raised to 4 minus 8x squared plus 16. I hope this is clear. So now if you want some more information regarding this matter, you can search this online. So if you have some clarifications, please don't hesitate to chat. It is now your turn to answer the given exercises on your module. So stay safe and God bless.